This is our platform's high-level system design. We will explain it from the system architecture to the implementation of each part. Our FinSight platform adopts a full-stack modular architecture that connects a React front-end with the Fast API backend. On the front end, users can register, browse financial news, receive stock recommendations, forecast the price trends, and chat with AI financial analysts powered by RAG. The backend is organized into 5 main services: auth, news, recommender, forecast, and AI analyst, each handling a specific domain function such as user management, personalized recommendations, or RAG-based reasoning. For data storage, both MongoDB and PostgreSQL are deployed on our AWS EC2 server. MongoDB stores users' events, news, and chat sessions, while PostgreSQL with pgvector manages users' profiles and semantic embeddings. Additional components include machine learning models like LSTM for forecasting, RAGflow for the retrieve augment generation, and Ollama as a large language models engine. Let's start with an overview of the news browsing module. It consists of 3 main components as shown in the figure. At the data level, we automatically fetch financial news from Google RSS and MarketOx API. Each article then goes through normalization and deduplication. After enrichment with tickers and sector tags, we generate a 64-dimensional semester vectors and a 20-dimensional preference vector and store them in MongoDB and PostgreSQL. The recommendation engine applied a dual vector weight scoring mechanism. It computes cosine similarity in 2 space, the 60D space and the 20D space, and blend them using tunable weights. Additionally, a heuristic remove recently seen article and balance recency with diversity. Produce a rank slate of 9 personalized news items for each user. When users click, like, or bookmark an article, both the 64D semantic and the 20D preference vectors are adjusted through lightweight online learning, so the next round of recommendations reflects the user's evolving interest. Overall, the news browsing module delivers a low-latency, interpretable, and continuously adapted news recommendation system. And the stock recommendation module contains 3 core functions as shown in figure. The base recommendation engine works by the comparing 20D user and stock vector using cosine similarity, and user vectors and stock vectors both contain 11 industry preference and 9 investment preferences. We applied diversity penalties to avoid sector concentration and select the top K most similar stocks for recommendation. Advanced recommendations use multi-objective optimization with 4 key components: preference matching, risk-adjusted returns, diversification benefits, and market timing. The system dynamically weighs these components based on the user's selected risk profile. Each stock receives component scores that are combined into a final recommendation score with detailed explanation for the transparency. And our system continuously learns from user interaction through incremental learning. Different behaviors have different learning rates, like clicks, dislikes. The system updates both sector preferences and investment characteristics based on interactive stocks. The real-time profile reconstructed ensure recommendations become increasingly personalized with each interaction. That's all for stock recommendation module. And in the stock forecast module, the core functionality includes obtaining personalized stock data through the recommendation engine, apply machine learning method to predict stock trends, and computing the confidence level of each prediction. In the key forecasting functionality, the module provides 6 prediction methods: LSTM, transformer, SQL to SQL, Light GBM, Profit, and ARIMA. Define an unified forecasting class to allow extension of additional forecasting modules. Each method constructed its own model based on its underlying principle, and by using historical stock data for training and influence, the module generates short-term stock trends predictions. The AI Analyst module integrates Rackflow and Olama to provide retrieve augment, financing raising, and personalized macro insights. All chat session and user interaction are stored in MongoDB, ensure contextual continuity and persistent session memory. Connected to market data APIs for real-time metrics with live financial information. And the AI Analyst user interface mainly consists with these three parts: the macro metrics, which are real-time metrics get from the specific API, the knowledge base and the model, which you can change your model and your knowledge base, and the final part, you can chat with the analyst to get whatever you want. And for the knowledge base and the model, the RAG is powered by the Rackflow, which creates our own knowledge base, use all large language model if you like. And we also deploy the DeepSeek R1 8-byte powered by Olama, and use different embedding models and re-rank models, and all chat sessions can be managed here. And the last part is we create a chat session after the user initiates a conversation request and persists it in MongoDB, and store the subsequent conversation from the same session in the chat history. And that's all. Thank you.